Ami, berarti kina bari ba?
Good evening to all. So for this session, it's better if you have a notes with you. Otherwise, you won't be able to follow. So I'm going to discuss some topics which while discussing, you have to write it down. Otherwise, it is difficult to follow these topics. Okay, let us start the session. So the first topic is minimization of Boolean expression. So minimization of Boolean expression. So if we have any complex circuits, okay, if you have complex circuits, and if you have designed those complex circuits using some logic gates, okay, and if you require many number of logic gates to design that particular circuit, so then it means if more number of logic gates are used, then the circuit may become a complex one. Okay, so if you want to reduce the logic gates, okay, if we are able to design the circuit using very few number of logic gates, then for the given input, you will get the output very quickly. Then cost of that circuit will reduce, and the power consumed by the circuit will also reduce. Okay, so for that reason, we need minimization of Boolean expression. So this topic is different. That's the reason because of which we need this topic. So we have to learn how to minimize the Boolean expression. Why? Because if more number of logic gates are there in the given circuit, then the circuit will become more complex. If the number of logic gates are reduced, then speed can be improved, you will get output quickly, the cost can be reduced, and power consumption can be power consumption can also be reduced. Okay, so there are two methods by which we can simplify the circuit, to increase the speed, to reduce the cost, and to reduce the power consumption. There are two methods. Those two methods are, first one is Boolean algebra method, next is K-method. Okay, so Boolean algebra and K-math, these two are the two methods. So you can note it down. So next. So let us start with Boolean algebra method. So in this Boolean algebra method, we are going to implement different laws, distributive law, associative law, complement law. So different Boolean laws or Boolean rules. I hope you might be knowing the Boolean laws and rules. So those laws and rules are implemented here. Those rules are followed here. And here we will not use any logic gates here. Simply what we are going to do is of course, even if a logic diagram is given, we can write an expression from that logic diagram and we can simplify it. Okay, we can do that. If logic gates are there, it doesn't matter. If a circuit is designed using logic gates for that circuit, you can write a Boolean expression and later you can follow these rules, Boolean rules or laws, to get a minimized circuit. And for that particular minimized circuit, once again you can draw a simplified logic circuit diagram. Okay, so here this method mainly it focuses on applying algebraic manipulations to reduce the complexity of the expression by eliminating the redundant terms. Okay, no need to write this. Simply if you write Boolean algebra, that is more than sufficient. So let us see how to get how to reduce these complex expressions, okay, into simpler form. So see here, you just copy it down. Here we have to simplify the Boolean function. Okay, that's what our question is. So what is our function here? F equal to AB. One second, I will just modify this. I will send this function F. This is our function. So function is F equal to A into B plus A into C whole bar. This is whole bar. This is A. Sorry. And I will write here itself. This is A, C whole bar. Okay, this is AC whole bar plus A, B bar plus into C into AB plus C. So instead of writing bar, I have put an hyphen here. It's you can, if you want, you can do that. Otherwise, you can put whole bar here. Okay, you can write like this. Instead of putting this hyphen, you can remove this. Okay, the cursor won't listen to me actually. So, wait, for your sake, I will just modify this. I'll remove this and for that you can understand and you can follow me. So see, this is AC whole bar and this is A B bar C into AB plus C. This is the expression. Okay, this is the expression F equal to AB plus AC whole bar plus A B bar C into AB plus C. This is the expression. So let us write down the expression in the solution. Same expression which has been given. I have written it here. So meaning of this term is AC whole bar. This is B bar. Okay. So I'm erasing, no, I will erase only two terms. Okay. So now here you just observe here carefully. Total how many variables are there? A, B and C. Total 3 variables are there. So it's a 3 variable system. Okay, it's a 3 variable system. So if you observe here, AC whole bar is there. AC whole bar, you can write A into C whole bar. This is AC whole bar. Don't bother about this line. You can write it as A bar plus C bar. A bar plus C bar. AC whole bar, you can write it as, according to Boolean rule, AC whole bar is equal to A bar plus C bar. So that is it. Here in the note I have written here. No need to write this. Just to explain you people, I have written like this. AC whole bar equal to A bar plus C bar. So instead of AC whole bar, you can write A bar plus C bar. So now AB as it is I have written here. Next A bar plus C bar is what? A bar, sorry, A bar, C bar is A bar into C whole bar is A bar plus C bar. A into C whole bar, this is A into C whole bar, that you can write it as A bar plus C bar plus, as it is, whatever expression is there, this expression a b bar c, you can multiply with a b bar c into a b plus a b bar c into c, a b bar c into c. Simply we have expanded this expression, isn't it? We have expanded this expression. This whole term is the expansion of the above expression. So I hope you are able to follow. Okay, I hope you are able to follow. So now just carefully observe this expression. Just observe this expression. So in this expression, if you see, in this term, there is a b bar and there is a b. And we know b into b bar. B, my cursor won't listen to me. We have b into, I don't write, wait, b into b bar. B into b bar will be equal to 0. B into b bar equal to 0. Okay. So here b bar is there and b is there. So you can replace b into b bar by 0. Okay. And here if you observe c into c. Okay. C into c is there. So c into c, already I have written there, but once again I am writing it here. C into c is c. C into C is C. That's what I have written here in the note. B into B bar is 0. C into C is C. So B into B bar is 0. This whole term will become 0. This whole term will become 0. And C into C is C. So just to copy AB as it is. A bar, C bar. This whole term has become 0. Write 0. And here C into C is C. So A, B bar, C. Okay. So is there any confusion till now? You can mention in the chat box. Were you able to follow till now? Just type Y if you are able to follow. If you want to repeat, if you want me to repeat, you just type R. So you must know the Boolean rules or Boolean laws. Okay? Boolean algebraic laws, De Morgan laws, and Boolean rules. If you have the knowledge of those rules and laws, you have to by heart them. Then only you can go for simplifying the Boolean expression. Anyone, if you are following, if you are able to understand, type Y, and if you want me to repeat, type R in the chat box. Okay, I will check here. Are you able to follow or not? If can anyone mention in the chat box? Till now, no reply. Yes, you are able to follow. Okay, only one message I saw. Okay then. Okay. So up to here, it's okay. Now let us proceed. Let us proceed. Okay. So just carefully observe here. A, B plus A bar is there plus C bar plus 0. 0 you can neglect it. In the next expression, you need not write it. So now in the above expression, if you observe AB is there. Where is AB? Here AB is there, isn't it? So here AB is there in this expression. So instead of AB, you can write AB into C plus C bar. Why? Why? Because, I'm sorry. Why? Because C plus C bar is equal to 1. Okay. C plus C bar is equal to 1. C plus C bar is equal to 1. So even if you multiply any number or any variable with 1, it doesn't matter. Okay, we won't bother about 1, isn't it? That's why you can write, instead of writing AB, you can write AB into C plus C bar. Okay. So your equation will not be modified. Why? Because C plus C bar is nothing but 1. So AB into C plus C bar, you just write it down. Okay. So in the previous equation, what was there? Only AB was there. Okay. Here only AB was there. In the next expression, what did I do? I simply added C plus C bar. So AB into C plus C bar. This is what you will get, and the remaining terms write down as it is. A bar, C bar, A B bar, C. See, A bar, C bar, A B bar, C. As it is, you just write it down. Now expand this. AB into C, AB into C bar, AB into C bar. Okay, and remaining terms write down as it is. A bar, C bar, A B bar, C. Okay. So now this is our equation. This is our equation now. Okay, this is our equation. Now here you just carefully observe. Uh, yeah, in this some common terms, you must search for common terms. If you see, the means which in which we can implement the Boolean algebraic laws or rules. Here A is there. You just observe these two equations, these two terms. A. See, so here C is there. Here C is there. And here B bar is there. Here B is there. Okay, so you can take AC common and you can write AC into B plus B bar. Okay, now these three terms are remaining leftover terms. So here you just observe here C bar is there. Here also C bar is there. So you can take C bar common and you can write AB plus 1. Okay, C bar into AB plus 1 and this term is left over, so write just plus A dash or A bar. Okay, so I hope you are able to understand. From this and this, I have written this expression. I took AC common. Okay, so AC into B plus B bar I got. Next, I have taken this equation. Sorry, not equation, expression and this term and this term. Okay. These two terms I have taken. In this, I have taken C bar common. So what is left over? Here AB and here 1. Okay, AB plus 1. That's it. And here A bar is left over. So A bar as it is I have written here. Now what is B plus B bar? B plus B bar is 1. AB plus 1 is also 1. According to one of the Boolean algebraic rules, AB plus 1 is also 1. Okay. According to Boolean algebraic rules, AB plus 1 is also 1. Therefore, replace B plus B bar with 1, okay, and AB plus 1 with 1. So if you do that, okay, so you can replace this with 1, you can replace this with 1. So what will happen to our equation? AC is left over, AC. Here C bar is left over, C bar. Here A bar is left over, A bar or A dash. So AC plus C dash plus A dash, I can say. Or AC plus C bar plus A bar. Now here once again if you observe, A bar is there and AC is there, isn't it? And here C dash is there. Okay. So one of the rules that I have implemented here, here nothing is there to take common. Okay, A bar is there, AC and C bar is there. Nothing is there to take common. But if you observe here, this is, sorry, my cursor is very sensitive cursor. Here if you see A bar plus C bar. So A bar plus C bar is equal to what? A into C, sorry, A into C whole bar. I couldn't write that whole bar. I have an issue with my cursor. It's not an issue, it's very sensitive. I should not press it too hard. Otherwise, yeah, okay. A bar plus C bar is nothing but AC whole bar. So that's what I have written. AC plus AC whole bar. Okay. So it looks like, okay. Here if you observe, it looks like AC, let us assume AC is some X plus AC bar. Instead of that, I can write, instead of AC bar, I can write X bar. X plus X bar is nothing but what? 1. Okay, so AC plus AC whole bar is 1. So at last, for the given Boolean expression, what is the reduced expression I have got? I have got a single term that is 1. So were you able to follow? You can mention in the chat box. Do you want me to repeat? Were you able to follow? Just mention why if you were able to follow. Or if you want me to repeat, you can mention. Or I'll go to the next numerical problem. You just mention yes, Y or C. Were you able to follow? Okay, then I'll proceed. Next, let us see another numerical problem. So, what is our question? Question is to minimize the Boolean expression. Okay, to minimize the Boolean expression using algebraic manipulation. That is using Boolean laws and rules. Okay, as well as De Morgan laws. Okay, so the given expression is this is the given expression. Okay, so f is a function which is represented by these terms. So how many variables are there? A, B, C, D. Total 4 variables are there. Okay, 4 variables are there. Now, I did not, as it is, copy this question in the solution. You just write it down. You just write it down. So now you just carefully observe. This is the question. You just copy this whole term in the solution. I didn't copy it. I can do that. It won't take much time. I will do that so that if you as you people are copying, you will also do the same. Okay. Now, as it is, I have copied the question. Now here you just search for the common terms and which search for the terms which can be easily eliminated using the Boolean laws. So if you see my first expression A, B, C bar, D bar is there. So let me search for any total 4 variables are there. Among 4 variables, is there any other term which has 3 variables common to this? Let me search. So ABC bar, ABC bar. Here D dash, D, D. Okay. So these two are see. If just compare these two. ABC bar, ABC bar. Here D bar is there. Here D is there. So here I can take ABC bar common. What is left over? If I take ABC bar common, D bar plus D. So what is D bar plus D? It is equal to, you can type answers in the chat box if you are able to follow. So D bar plus D is equal to what? 1. D bar plus D is 1. Okay. So I hope if you are listening, you will be able to follow. A, B, C bar, A, B, C bar. So A, B, C bar, from these two terms, I have taken A, B, C bar common. What is left over? D bar plus D. So d bar plus d is nothing but 1. Okay, now let us search for a few more terms which you have to eliminate some terms. Okay, by some or the other method. Okay, by using Boolean laws, we have to eliminate. So A, B bar, C bar, D. So let me search A, B bar, C bar, D. A, B, C is there. Three terms should be common. A, B bar, C. I can, yeah, I can use this. A, B bar, D is there. Yeah, A, B bar, D is there. I can use that, but I did not. Did I use that here? A, B bar, D. So this you can do that, but I have not done this. A, B bar, D. A, B bar, D. Did I write anywhere? I did not write. Okay, you can do that. A, B bar, D. If you take common, what you will get? A, B bar, D into C bar plus C. You can do that. But here in the next step, I did not do. I did not solve like that. So what this solution for these two terms I have taken these two terms now. In these two terms I can take that, but I didn't do that. It's okay. Whatever I have written, you will better follow this. So that is also correct. But I have left this A, B bar, C bar, D. I left it. After that I have gone for A, B, C, D. And yeah, if you observe this term and this term you just see A, B, C, D, A, B, C, D, D dash or D bar. So here you can take, where is it? I didn't even take that also. Here also you can take A, B, C common and you can write D plus D dash. So you will get A, B, C. That also I didn't do. What did I do? Okay. A, C, D bar. Where is A, C, D bar? This is A, C, D bar. A, C, D bar. Okay. So this has B. So where is another term ACD bar? ACD bar, here it is there. Okay. So what I have done in the next expression is ACD. This is ACD. Did I forgot any bar? No, 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 I did not. I might have forgotten. Okay. So if you see here, if I'm following this, it's better if I go on typing. That is more easy for me. So, okay. So we have completed these two. And I have written this one as it is. Okay, A, B bar, C bar, D. Here I have taken ACD common. So here B is there. Let us check for ACD. Yeah, here nearby, second term. Okay, I have taken these two terms. Okay, I have taken these two terms. ACD, I have taken ACD common. B plus B bar I have written here. Instead of that, you can go for the, as I have already told you, you can go for the D plus D bar earlier, whatever we have got, you can do that. Or here, this is also okay. A, C, D, I have taken common. B plus B bar you will get. Later on, A, C, D bar. Where is A, C? Here A, this is C, this is D bar, okay. Here A, this is C, this is D bar, okay. So these two expressions, okay, all right. Okay, these two expressions I have taken. Okay, from that I have taken AC D bar common and B plus B bar. Okay, so earlier what I told you, that was also correct. See, when we are simplifying expressions, everybody will not think in the same pattern. I myself, when I solve once, I will think certain pattern. When I start to solve the same equation in this when second time, I will start solving in some other pattern. So my way of thinking will not be same always. That's why. Okay. So I hope you are able to follow ABC bar. ABC bar. I have taken common and within brackets D bar plus D you will get. Next second term as it is I have written here. Okay, and these two I have solved. I have got this expression. Okay, this one. Next, I have solved these two. I have taken ACD common, and I have got this expression b plus b bar I have got, and later on I have solved this expression, and this is it. I have got this expression from that. Simply taking some common terms, three terms common, and single term uncommon term, in putting them in a bracket. Okay. So here d plus d bar means 1, b plus b bar is 1, b plus b bar is 1. Okay. So so these are 1. So what is left over? Left over is a b c bar, a b bar c bar d, a c d, a c d bar. This is what is left over according to what I have written here. Okay, so if you are able to follow, you can solve on your own and you will get some expression. And the last answer may not be same for everyone, depending on how you are solving. Okay, so it is not necessary to get the simplified expression same always. Okay, it depends how you are solving it. So this is it. Now let us see how to simplify further to get the simplified small equation. So let us see how to simplify further. Here I have ABC bar, I have A bar, B bar, C bar, D. I have ACD plus ACD bar. So ACD plus ACD bar, I can solve it, isn't it? I can take AC common, and I can put D plus D bar in the brackets. Okay, so that's what I have done. A, B bar, A, B, C bar as it is I have written. A, B bar, C bar, D as it is I have written. After that I have taken AC common, I have written within brackets D plus D bar. D plus D bar is what? It is 1. So as it is A, B, C bar, you just write it down. A, B, C bar, D bar as it is, you just write it down. Here D plus D bar is 1. So what is left over? AC. Left over is AC. So were you able to follow, or you want me to repeat till now? Just type Y so that do you want me to repeat, or are you able to follow, or shall I proceed? If anyone wants me to repeat, just type R. Okay. So I hope you people are writing. If you won't write, you won't be able to follow. Simply looking at the equations is not sufficient enough to learn the concept. Okay. Now let us proceed further. Okay. Let us proceed further. So from the above expression, I have taken A common here. See, in all the terms A is there. Where is it? Oh, yeah. So in all the terms A is there, but what I have done is I have considered A, B bar, A, B, C bar and AC. I have taken A, B, C bar and AC. From that I have taken A common. If I take A common from those two terms, what do I get? B, C bar, A into B, C bar plus C U. This is what I will get. Plus leftover term is what? A, B bar, C bar, D. Okay, A, B bar, C bar, D is left over. Now this B, C bar plus C is there. B, C bar plus C is there. So I will, instead of writing with cursor, it's better. I will I will write in text. So here B, C bar plus C is there. I will change the ink. Yeah. So B, C bar plus C is there. It can be written as according to one of the Boolean algebraic rules, it can be written as B plus C into, okay, B plus C into C bar plus C. Okay, this is it. So here, if you see here, what is there? B, C bar plus C is there. Okay, B C bar plus C is there. According to one of the Boolean algebraic rules, B C bar plus C, it can be written as B plus C into C bar plus C. So C, this C is there, C is there, this C, it can be added with B as well as with C bar. Okay, so I will try laser. So B C bar plus C, it can be written as what? B plus C into C bar plus C. So what is the next term? A into B plus C into C bar plus C plus A B bar C bar D. The same term which is there above, I have rewritten like this. Okay. So C plus C bar is what? C plus C bar is 1. We already know C plus C bar is 1. So what is left over? A into B plus C plus this term as it is, write it down. A, B bar, C bar, D. Okay. Now multiply A with B and C. So AB plus AC you will get plus A, B bar, C bar, D. Okay. Next, here, this is what our expression is. Here you can see in all terms A is common. I might have taken A common in the previous slide itself. I will just yeah, remove this laser. Uh, Here also I might have taken A common. Even if you take A common in this step itself, that is not wrong, but I didn't take that. But if you want, you might have taken A common earlier itself. It's okay. It might not have been wrong. So now what is here? You just take A common. You just take A common. What is left over? B plus C plus B bar C bar D. Okay, B plus C plus B bar C bar D. So here once again, okay, here once again, which equation? Now in this equation, I have kept C aside. Okay, I have kept C aside. So what is left over? B plus B bar C bar D is there. B plus B bar C bar D. You can write it as, okay, you can rewrite it as B plus B bar into B plus, okay, B plus B bar into B plus C bar D. According to one of the rules, Boolean algebraic rules. Okay. So here I didn't consider, I have kept C as it is. Okay. This is it. So I have kept C as it is. I have kept C here. I have sent C here. I have considered only two terms here. I have considered B and B bar C bar D. Okay. So in this B bar C bar D, in this B bar C bar D, I have considered B bar as one term and C bar D as another term. So what I can put a dot here. I can put a dot here. So what is this? B plus B bar into C bar D. So if you apply the Boolean algebraic rule, according to one of the rule, so you can write it as B plus B bar into B plus C bar D. Sorry, here plus C is there. I didn't notice that. Here plus C is there. I didn't notice that. It might have come from the previous expression. So I just modified this from the previous one. So I forgot to delete that C. Okay. So this is what you will get. So here B plus B bar C bar D. So here I have considered B bar as one term, C bar D as second term. So let us this is, if this is X, B is X, B bar is Y. The cursor won't listen to me. This B bar is Y. C bar D is Z. So x plus yz is equal to x plus y into x plus z. So here x is equal to b. Better, I will just reduce this. So in order to make it more easy for you to understand, here x is equal to b, y is equal to b bar, and z. Z is equal to, what is it? C bar d. Okay. So x plus, plus x plus yz is equal to x plus y into x plus z. That's what I have done. Okay. So that's what I have done here. So I hope you are able to follow. Say b plus b bar c bar d. I have written it as b plus b bar b plus c bar d. So here I have considered some b as x, b bar as y, and z instead of z as c bar d. So if there is an equation x plus yz, then that can be written as x plus y, x plus z. So what is x? B. What is y? B bar. So b plus b bar. Okay. Okay. So x plus y is b plus b bar. X plus z is what? X is b, z is c bar d. So b plus c bar d. I hope you are able to follow. Okay. I hope you are able to follow. Now we have b plus b bar. That means b plus b bar is 1. So what is our next expression? A, as it is, write down A, as it is, write down C. B plus B bar is 1. What is left over then? B plus C bar D. B plus B bar is 1. So what is left over? B plus C bar D. Just write down B plus C bar D here. Okay. So here A into C plus B plus C bar D is, that's what you will get. So A into C plus B plus C bar D you will get. Now here, if you carefully observe, there is a C, there is C bar D. It is similar to, what? X plus YZ of, isn't it? It is similar to X plus YZ. So see here I have shifted this C this side and B this side. That's it, nothing else. Next expression. In the next expression, simply I have sent B this side, C this side, so that these two will be together. So C plus C bar is there. So what do you get? C plus C bar. C plus C bar D, you can write it as C plus C bar plus C plus D. Okay, so using this law, one of the Boolean rules. Okay, so using this Boolean rules, you can write C plus C bar D as C plus C bar into C plus D. Okay, so what is C plus C bar? C plus C bar is 1. C plus C bar is 1. So C plus C bar is 1. So what is left over then? So A is left over, B is left over. What else is left over? C plus D. C plus D is left over. So A into B plus C plus D. Now multiply A with this whole term, otherwise leave it as it is, your wish. So our simplified Boolean expression AB plus AC plus AD. Okay, AB plus AC plus AD is our simplified Boolean expression. So if anyone wants me to repeat, you can mention in the chat box. I will repeat, otherwise I will proceed. So if you see here, this was the expression, which was a big expression. Now we have reduced it. So you can write F here. F is equal to what now? F is equal to AB plus AC plus AD. So shall I proceed? Yes. Okay, then I'll proceed. Now we have solved two numerical problems using Boolean expression. Now let us see what is meant by K-map. Okay. So in Boolean expression, we have seen we have to implement some Boolean laws or Boolean rules to get the simplified expression. Okay. So which is somewhat hectic. isn't it? You have to remember all the Boolean laws, otherwise you can't solve it. So, whereas this K-map is a graphical method, it's a graphical technique or graphical method. So here, there is no need to implement such laws, but there are some very few rules that you should remember. Okay, if you remember those rules, then you will be able to get the simplified expression. Our main aim is we want to reduce the complexity of the given circuit. Okay, so if there are many logic gates in the given circuit, we have to simplify the expression by using either Boolean algebra or by using K-map. We want to simplify it. For the simplified form, you can draw the circuit which will have very few number of logic gates. Okay, so this is a graphical method for simplifying the Boolean expression. So we can draw the K-map for two variables. Okay, two variables means, let us assume if A is one variable, B is another variable. Okay, B is another variable. If A is one variable, B is another variable. So each will have a magnitude of, means each variable will be represented by only one bit. Okay, each variable is represented by only one bit. So you can draw the K-map by for two variable system. Here I think it is there, it is mentioned here itself. For two variable, okay, you have to draw four squares. Four squares are required. Okay, and each square will have only one term. Each square will have only one term. So here you can see four squares are there. You can provide numbering to the square. You can start with this box 0. Next 1, 2. So numbering should start from 0. Okay. So okay. So a K-map can be drawn for drawn in two forms, in SOP form and POS form. SOP means sum of the products form. Okay. And POS, that is product of the sum. So what is product of the sum? What is sum of the products? I will tell you. So in sum of the products, if you see, this is a product, this is a product, this is a product, this is a product. All the products are added together. So that is known as sum of the product. In product of the sum, this is the sum, this is the sum, this is the sum, and this is the sum. All the sums are multiplied. So if all the sums are multiplied, that is known as product of the sum. If all the products are added, that is known as product sum of the product. Okay, you try to understand. Be patient and listen carefully, otherwise you won't be able to follow. So if you see here, I have given numbering to each square box. Total how many boxes will be there? For two variable system, there will be four boxes. So our variables are what? A and B. A and B are our variables. Okay. So A and B. B can have only two values. One is B, other value is what? B bar. A can have two values. One is A, other value is A bar. That's it. So first write down B bar, next write down B. Here first write down A bar, next write down A in front of each box. Okay. So here total four boxes are there. Write A, write B, write down first above this first box, write down A bar, B bar, and after that write down B. In front of this box on the side, write down A bar, next write A. So here B bar means 0, B means 1, A bar means 0, A means 1. So what is it in this first box? Just look at the top and left side, top and left side. What can you see? You can see on the top B bar is there, on the left side A bar is there. So write down A bar, B bar. Okay. Similarly, for the next box, In the next box, on the top B is there. On the left side, A bar is there. So A bar B. Okay. Next, here, look at the top. B bar is there. On the left side, A is there. A B bar. Next, look at the top. B is there. Look at the left side. A is there. So A B. So each box has its own magnitude. Okay. It has its own product, we can say. Okay. So all these products are to be added. Okay. Each box will have its own product. Instead of writing A bar, B bar, okay, here what is there on the top? 0 is there. Here on the left side, 0 is there. So 0, 0. Instead of writing A bar, B bar, I can write 0, 0. So in this box, 0, 1. In this box, 1, 0. Here, 1, 1. Okay. You have to simply look at the left and look at the top of each box. And numbering is what? For this box, numbering is 0. For this box, 1, 2, cursor, 3. Okay, 0, 1, 2, 3. 0, 1, 2, 3. So now you can write down all the products and you can add them. So that's what I have done. Function has two variables, A and B. Okay, so what are products that I have got? So instead of writing like this, I can write, no, so if you are writing in terms of, it has to be written in terms of variables. You can't write in terms of zeros or ones. But for the you can, in how to represent in the K-map, you have to write in terms of zeros and ones. How to write it, I'll tell you later on. So now let's go to POS, product of sum. So here same thing. Numbering is 0, 1, 2. So how to give this numbering? There is a specific rule that is to be followed to provide the numbering. I'm not going to discuss that rule now because now it is not necessary. Already we are going very slowly. Okay. Already the class is going at a slow pace. So that's why I don't want to discuss how this 0, 1, 2, 3 numbering is given. Randomly, it looks like it is in a sequence. Okay. Now, if you see here, on the left side, it is product of sum. So all these sums should be there in each box. So here, what is there on the left side? A. Write down A. Okay. So here, for the product of sum, if 0, first you must write B, and next box you must write B bar. Only for A, first box you must write A, and for next box you must write A bar. It is reversed to the sum of the product. Okay, that you remember. So for sum of the product, here you have written first B bar, next B, and A bar and A. So if you see product of sum, B, B bar, A bar. B means 0 here. 0 and 1 did not change. For sum of the product, 0 means B bar. For product of the sum, 0 means B. Remember that. For product of the sum, 0 means B or A. Okay. 1 means B bar or A bar for product of the sum. Whereas for sum of the product, okay, for sum of the product, 0 means B bar and A bar, and 1 means B and A. Okay, that is it. So write down the sum in each box. A plus B. Here, A, B bar, A bar, B, A bar, B bar. So write down all the magnitudes and multiply them. This is product of this sum. So are you able to follow or not? Just mention in the chat box. Are you able to follow or not? Or you want me to repeat anything? Just type in the chat box. I will repeat that. Okay, you are able to follow? Shall I proceed? Okay then. Similarly, this is for two variable system. I think I have deleted some slide has been deleted. Unfortunately. Yeah. Some of the products. Yeah. So next one is K-map for three variable. This is three. Okay. So K-map will have K-map with three variable system. Okay, it will have 8 squares. It will have 8 squares, and each square will have one term with three variables. Now let us see how. Okay. Okay, sir. If time permits, I will make a video on SR flip-flop and JK flip-flop. At present, I'm just teaching this K-map and Boolean expressions on safe side, so that students should be able to follow if they have to draw. So now let us see this SOP, yeah, sum of the product. I hope you have understood. SOP means what? Sum of the product. So now, how many variables? If this K-map is a three variable K-map, so sorry, three variable K-map. So here, how many squares will be there? Total 8 squares will be there. So you just see one, okay, one, two, three, 4, 5, 6, 7, and 8. Total 8 squares are there. Total 8 squares are there. And you have to provide numbering to each square. You should start with 0. After 0, 1. Okay? 0, 1. After that, you should not write 2 here. You should write 2 here. Okay? You should jump 1 square and write 2 in the next box. And once again, come back and write 3. Okay, once again come back and write 3. There is a specific reason why we have to jump one box. Okay, at present I am not going to discuss about it because we don't have sufficient time to discuss. Okay, that's the reason. I'm not going to discuss why we have to jump one square and go to the next box and write 2 and once again come back and write 3. Similarly, go to the lower box, numbering, provide the numbering. Provide the numbering. So here it is 4. Next 5. Now once again jump. Jump to the next box and write 6. And next once again come back and write 7. Okay. So this pattern you have to follow. So why we have to follow that I am not going to discuss now because of the time limit. So but if you have to follow this pattern, nothing much complicated. Okay. So there is nothing much complicated to follow this pattern. Okay. So I'm unable to put that bracket. Okay. So 0, 1, see here, 0, 1, jump one box, write 2, come back, write 3. Next, go to the next row, 4, 5, and jump one box, right? 6 and come back. Okay, 0, 1, jump, 2, come back, 3. Go to the next row, 4, 5, jump, right 6, come back and write 7. So 0 to 7. Okay, now write down A and write down BC on one side. Okay, and write A on the other side. So here A, right in front of the first row, write A bar, and in front of the next row, write A. And here above BC is there, so just write B bar C bar, next B bar C, BC, B C bar. How to remember this B bar C bar, B bar C, BC, B C bar? So for that I will tell you. So what you do is simply no need to nothing to worry much. At least you can remember how you have to write. You have three variables, isn't it? A, B, C. It's a three variable K-map, and you have three variables A, B, C. Okay, write A on one side, B, C on the other side. This I hope you can do that. Now for the first box, write 0, 1. Next for the above boxes, write 0, 0. Next 0, 1. Okay, 0, 0, 0, 1. Next, jump one box, right? 1, 0. Come back, right? 1, 1. What is 0, 0? 0, 0 is 0. What is 0, 1? It is 1 in decimal. What is 1, 0? It is 2 in decimal. What is 1, 1? It is 3. Okay, see here we have given numbering in decimal form, isn't it? We have given numbering in decimal form. Okay, we have given numbering in decimal form. So, numbering in decimal form. So that pattern you can follow. So first of all, write. Where is my cursor? First of all, write 0, 0. Next 0, 1. Here 0 is there, here 1 is there, here 3 is there, here 2 is there. So same thing in binary form, write down 0 means 0, 0. 1 means 0, 1. 3 means 1, 1. 2 means 1, 0. That's it. Don't worry about the next row. Just look at the above row. And from that, based on that, you just write down. Here 0 is there. Write down 0, 0. Here 1 is there. Write down 0, 1. 3 means 1, 1. 2 means 1, 0. That's it. Now, after that, 0, 0 means what? B bar, C bar. Here BC is there. So B bar, C bar. 0, 1 means B bar, C. BC means, 1, 1 means BC. 1, 0 means B, C bar. Okay, 0 means what? B bar. 0 means C bar. 0 means B bar. 1 means C. 1 means B. 1 means C. 1 means B. 0 means C bar. Okay, so here it is 0 and 1. 0 means A bar, 1 means A. Okay, so from this, so here, okay, so here from just look at for this box, look at the top. B bar, C bar is on the left side, A bar is there. So A bar, B bar, C bar. Okay, so this is the product. In each box will have a product. Okay, go to second box. What is there on the left side? A bar. Okay, on the left side, A bar is there. Write down A bar. Top, B bar, C. Okay, next on the left side, A bar is there. A bar, top, BC. A bar, BC. On the left side, A bar is there for this last box. So A bar, B, C bar. A bar, B, C bar. Similarly, go to the next box number, what is it? Whose number is 4. So look at the left. A is there. A, top, B bar, C bar. Next, for the square box number 5. So what is it? A, left side A, top, B bar, C. For 7, box number 7. Okay, so numbering. Okay, box numbering is 7. So look at the left A, top, B, C. A, B, C. For box number, whose number is 6. Look at the left, that is A, top, B, C bar. Okay, now write down all these products and add them. Add all these products. That's it. A bar, B bar, C bar. A bar, B bar, C bar. I forgot dot. I have forgot to put the dot here. I forgot to put dot. So did I forget anywhere else? No, I didn't forget anywhere. Only that dot is missing. Okay. So let me expand the screen. So you just add all these products. This is it. This is our this is the function ABC for the sum in terms of sum of the product. If anyone wants me to repeat, you just mention in the chat box. Shall I proceed? Or you want me to repeat? Anything which is not understood by you. I'm trying my best to make it more clearer to you people. So if you listen, you will be able to follow. If you are writing, you will be able to follow. Shall I proceed? Or do you want me to repeat? Yes, shall I proceed? Okay then. Okay, I'll proceed. Sum of the product, next product of sum, product of the sum. Similar to the previous case. So here, what you have to do is, here, similar to your previous case, you can write A here, but on the other side, okay, at the corner, okay, on the left side top corner, isn't it? Here you have written A, but here you should not write BC. Okay, in the SOP, we wrote BC, isn't it? But here you should write B plus C because this is product of the sum. Okay, all these sums are to be multiplied. First of all, we have to add, later on we have to multiply. So this is product of the sum. So you must write B plus C. So A, B plus C. So similar to previous case, here also you can write 0, 0, 0, 1, 1, 1, 1, 0. Okay, this is 0. So 0, 0. This is 1, 0, 1, 3, 1, 1, 2, 1, 0. Okay. I hope you are able to follow. This is 0, right? 0, 0. This is 1, right? 0, 1. This is 3, right? 1, 1. This is 2, right? 1, 0. If you want, if for your own satisfaction, you can write 0 plus 0, 0 plus 1, 1 plus 1, 1 plus 0 for your own satisfaction. If you want to satisfy yourself, you can write plus here. It doesn't matter. You write plus here, but don't add. If you want, you can write plus here. Okay. It is not wrong. So write 0 as usual, 0 and 1. But if you remember, I have already told you that for product of the sum, for product of the sum, if 0 is there, 0 means without complement. 1 means with complement. So here 0, 0 is there. So B plus C. Here 0 and 1 is there. Means B plus 1 means C bar. Complement. 1 means complement. So here 1 is there, 1 is there. So B bar plus C bar. Here 1 plus 0 is there. Means B bar plus C. A 0 means A, 1 means A bar for product of the sum. Okay, for product of the sum, uh, 0 terms will not have complements. 1 terms will have complements. So now go to the first box, first square. First square. Numbering is same, similar to your previous case. See, where is my cursor? Numbering to each square box is same. 0, 1, jump 2, next come back 3, 4, 5, jump 6, come back 7. Okay, that's what. So numbering, this is numbering. Now let us write down the sums. A, look at the left side. A, top, B plus C. So A plus B plus C. Okay, not A into, it is A plus. All the terms should be added in product of the sum. Next, go to the next box. Look at the left, it is A. So A plus, look at the top, B plus C bar. Next, go to the third box. Left side A. A plus B bar C bar. C bar, B bar plus C bar. Next, fourth box. Left side A, top, B bar plus C. Similarly, go to the next bar. A bar, B plus C. Next, fifth, A bar, B, C bar, A bar. Next, seventh, A bar plus B bar plus C bar. Next, sixth, A bar plus B bar plus C. Write down all these sums and multiply them. Write down all these sums and multiply them. Okay, this is for 3 variable system. So let us proceed for next one. That is 4 variable system. K-map for 4 variables. 4 variable will have 6 squares. 6 squares. There will be six. Sorry, not six. 16 squares, not six. For 3 variable, 8 squares are there. For 4 variable, why it will there will be six. There will be sorry. My cursor won't listen to me. 16 squares. 16 squares will be there. So here you can see 16 square boxes. So see 0, 1, jump, give numbering 2, next 3, next 4, 5, jump, 6, next come back, oh sorry, come back, 7, next. So see, you have written up to 7. Next, you should not go to the next row. You must go to the last row. Write down 8, 9, jump one box, write 10. Next, come back, write 11. Next, go to the above row, 12, 13, jump one box and write 14. Next, 15. So why we are writing this numbering in certain pattern? There is a specific reason. I'm not discussing that. Okay. So just remember how to write this numbering now. That's it. So this is sum of the product. Similar to previous case. Here total 4 variables are there. So write AB on one side, CD on other side. A, B, C, D. Okay. A, B, C, D. Total 4 variables. A, B, C, D. Write AB on one side and CD on the other side. So write down now 0, 0, 0, 1, 1, 1, 1, 0. Same thing. On the this is on the horizontally. On vertically also follow the same pattern. 0, 0, 0, 1, 1, 1, 1, 0. Same pattern. Pattern will be same. 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Same pattern we have to follow. And above that, write down 0, 0 means C bar, D bar. Next, C bar, D, C, D, C, D bar. Okay. Similarly here, A bar, B bar, A bar, B, A, B, A, B bar. Same thing. And in each box we have to write down the product terms. Each box we have to write down the product terms. So what is there? On the left side, A bar, B bar. Write down A bar, B bar. Commonly you can write A bar, B bar. On the top, C bar, D bar. Write down C bar, D bar. On the top, what is there? C bar, D. Next, CD. Next, CD bar. Similarly, go to the next. A bar, B is there. So write down A bar, B in all the boxes in this row. A bar, B. On the top, C bar, D bar is there. Here, C bar, D on the top. CD on the top. Next, CD bar. Okay. Here on the left side, AB is there. So write down AB in this whole row. AB, AB, AB. Next top, C bar, D bar. Next, C bar, D, CD, and CD bar. Next, on the left side, AB bar is there. AB bar, C bar, D bar, AB bar. Write down AB bar. This whole row. Next, on the top, C bar, D bar. On the top, C bar, D, CD, and CD bar. Okay. This is SOP. And you can write down the function on your own. I didn't write. For the 3 variable and 2 variable, I have told you how to write it. For this, you write on your own. Okay. I want to continue. Already it is too late. So for POS also, simply here you have to write A plus B. Okay, here by mistake something extra has come. I didn't notice that. Okay, A plus B, C plus D. A plus B and C plus D is there. So 0, 0 means C plus D. 0 1 means C plus D bar. 1 1 means C bar plus D bar. 1 0 means C bar plus D. Here 0 0 means A plus B. 0 1 means A B bar. 1 1 means A bar plus B bar. And 1 0 means A bar plus B. Okay. And inside, so see here, what is there? First numbering, numbering, I have already told you, same pattern you have to follow. Okay, 1 0 1 jump 2 3. Okay, now on the left side start A plus B, top C plus D, left side A plus B, A plus B. In this whole row write A plus B, A plus B, A plus B. So in this A C D bar, C bar plus D bar, C bar plus D. Next, on the left side, A plus B bar is there. So write down A plus B bar, A plus B bar, A plus B bar, A plus B bar. Top C plus D is there. Write down C plus B bar, D bar, C plus D bar. Sorry, C plus D plus C plus D bar plus C bar plus D bar, C bar plus D. Next, in this row, A bar plus B bar is there. So write down A bar plus B bar, A bar plus B bar, A plus B bar, A bar plus B bar. Next, write down from the top C plus D bar, C plus D bar, add all the terms, that's it, nothing else. Same thing, okay? Same thing, nothing new. Whatever I have discussed earlier, almost similar, but number of variables have increased. That's it, nothing else. Okay? This you can write down the expression on your own. I have not written. You can write down expression on your own. So I hope you are able to follow. I just want to solve some numerical problem and conclude this topic. I think I have three numerical problems. I will discuss them as quickly as possible and I will conclude. So write it down. Reduce the following function. What is the function? F A B equal to A plus A bar B using K map. Okay. K means Karnaugh map. So I'll just show you the spelling. Is it there available here? Yeah, Karnaugh map. K means Karnaugh map. I forgot to tell that. Karnaugh map. So let us solve some numerical problems on this. Oh, they are very small numerical problems. You can easily able to follow. So numerical problem is what now? To reduce the following function f of AB equal to A plus A bar B bar using K map. Write it down. So if you observe here, this is the given equation. So it's a two variable system. It's a two variable expression or whatever. But here only A is there, B is not there. Okay. So how can you represent only A in your K map, even if it is a two variable? What we have seen. So what type of system is this? POS or SOP? Can anyone mention in the chat box? SOP form. This expression is in SOP form or POS form. Product of sum form or sum of product form. SOP or POS. Can anyone mention in the chat box? First of all, you must be able to identify whether it is in SOP form or POS form. Just mention in the chat box POS or SOP. It is in SOP form. Yeah. Yeah, it is in SOP form. So now even if it is an SOP form, it is a two variable system. It's a two variable system, A and B. So in this term, A is there, B is there, that's okay. A is there, B is there, that's okay. But in this term, only A is there, B is not there. Okay, we need at least two variables in each term. There should be two variables, then only you can represent in K map. So what I have done is, I have multiplied A with B plus B bar. We know B plus B bar is 1. So even if you write B plus B bar, it doesn't matter. Okay, it's not going to change the expression. Okay, so simply you multiply B plus B bar with A and expand it. So what do you get? A into B plus A into B bar. A into B, A into B bar. And what is already given in the expression? A bar B bar. What is AB in SOP form? if bar is not there, 1. If bar is there, 0. Okay. If bar is not there, 1. Bar is there, 0. So we have got 3 terms, isn't it? How many terms are there? 1, 2, 3. What is this A, B? 1, 1. A, B bar, 1, 0. A bar, B bar, 0, 0. 3 terms. Okay. Now we have got 3 terms. We have to, what to say? We have to represent these 3 terms in your K-map. So did you complete? Did you write? Just type C the chat box so that I will change the slide. I will conclude. I will conclude as quickly as possible. Now let us go to the K-map. So in the K-map, okay. So in the K-map, so what were our terms? 1, 1, 1, 0, 0, 0. So 0, 0. This is what? 0, 0. 0, 0 means A bar, B bar. A bar, B bar, 0, 0. So here we have A bar, B bar, 0, 0. There substitute 1. Next, what is there? 1, 0. 1, 0. 1 means this A. 0 means B bar. 1, 0. So this is 1, 0. Okay. So our terms are 0, 0. This is 0, 0. Another term is 1, 0. What else? 1, 1. 1, 1 means here 1 is there. Here 1 is there. So which one? This one. 1, 1. Did you understand? I'll draw the K-map. Okay. A, B. So this is B bar. B. A bar. A. A bar means 0. A means 1. Not 0, sorry. B bar means 0. B means 1. So what are all our terms? 3 terms were there. 0, 0 is there. This is 0. This is 0. So 0, 0. Another term 1, 0. This is 1. This is 0. So 1, 0. Another term 1, 1. This is 1. This is 1. So 1, 1. Only these 3 terms are there. So whichever terms are available in that particular box, put 1. Here 1. Here 1. Okay. You have to write 1 in the boxes where terms were available. Okay. So you had 0, 0. This is 0, 0. Isn't it? This is 1, 0. This is 1, 1. I hope you are able to understand. Okay. So 0, 0. So write 1. Next term is 1, 0. Write 1. Next term is 1, 1. Write 1 here. Okay. Now remember we can group two even numbers. Means we can, if we have so if nothing is there, you can write 0. Here nothing is there, so you can write 0 there. So now you have to group these numbers. Here how many ones are there? 3 ones are there. Group these numbers. You can group 3 ones, not 3 ones, sorry. You can group 2 ones or 2 boxes. You can group 4 boxes. Okay, you can group what? You can group 2 boxes or 4 boxes or 8 boxes or 16 boxes. So here, if you see, these two, in these 2 adjacent boxes, 1 is there. Means these 2 boxes, 1 is there. So you can group it. Just draw a circle. In these 2 adjacent boxes, 1 is there. Just group it. In these 2 adjacent boxes, 1 is there. You can group it. If a number has been already grouped, this 1 is already grouped, isn't it? I will just once again draw. So let us assume these 2 ones are these 2 boxes are side by side, in which ones were there. Have grouped it. This one, you know, it is already grouped. You can group it with n number of boxes. You can group it with the next number also. Any other number, you can group it any times. Okay. So once a box, a number, okay, is grouped. Okay. don't think that you can't group it with any other number. Okay, so here two boxes in adjacent boxes, one is there, group it. Okay, in these two adjacent boxes, I will take laser. Okay, in these two adjacent boxes, one is there, here one is there, here one is there, group it. Next, here one is there, here one is there, again group it. Okay, draw another circle. So how many groups did you get? Two groups. So there are two groups. Two groups you have got. Did you understand grouping? Okay. So we can group any two adjacent boxes or four adjacent boxes which have ones, or six, four, after four, eight. Eight adjacent boxes which have one, and 16 adjacent boxes which have one. Okay. For some of the products. Okay. For SOP form. For SOP form. Okay. Now here we have got two groups. In this, let us consider this first group. In this first group, what is common? In this group, A bar is in this box, A bar is there. In this box, A is there. So it is uncommon. If you look at the top, B bar is there. So B bar is common for this group. For this group, if you see on the left side, A is common. If you look at the top, B bar, on the top, B. So B bar, they are uncommon. But A is there. Okay. So for this group, B bar you have got. For this group, what did you get? A. So our reduced expression is A plus B bar. Reduced expression is what? A plus B bar. Did you follow or you want me to repeat? Did you follow or do you want me to repeat? It's already 9:30. I have to conclude the session. It's already late. Better I might have taken during the afternoon session. I thought I will take in the evening. So I didn't plan it earlier. Do you want me to repeat or shall I proceed? Okay, shall I proceed? Yes, means I hope. Okay. So if you want me to repeat, type R. Now let us consider three variable system. A, B, C. F of reduce, you have to reduce the function using what? K-map. Okay. So just check in all the expressions if all the terms are there. This is A, B, C, three variable system. So it's 3, 3, 3, 3, 3. That's it. So we need not worry. In all the terms, three variables are there. So we need not worry. So we need not modify the expression. Now write down the function. And this is A bar. This is SOP or POS? That you have to check whether it is SOP or POS. Can anyone mention SOP or POS? Can you mention in the chat box it is SOP or POS? Some of the product or product of the sum. Yeah, SOP. So it is SOP form. So it is SOP. SOP means what? If bar is there, you must write 0. If bar is not there, you must write 1. Okay, that you have to follow. So see here A bar, B bar, C bar is there. A bar, B bar, C bar means 0, 0, 0. Here A, B bar, C bar. A means 1, B bar, C bar, 0, 0. A bar, B bar, C. A bar, B bar, 0, 0. C means 1. A bar, B, C. A bar means 0, B, C. B means 1, C means 1. Okay. So I hope you have completed. Now you can draw the K-map. How many terms are there total? 1, 2, 3, 4. 4 terms are there. In 4 boxes, you have to write 1. Okay, in 4 boxes, you have to write what? 1. So what are those boxes? Let us check. 4 terms are there. 1, 2, 3, 4. 4 terms are there. In 4 boxes, you have to write 1. What are those boxes? Let us see. I hope you have completed. I'm proceeding. Already it's late. So this is our for three variables. 8 square boxes will be there that we have already discussed. So A, B, C, SOP form, A, B, C. Okay. So 0, 0, 0, 1, 1, 1, 1, 0. Here 0 and 1. So what are our terms? 0, 0, 0. So here you see 0, 0, 0. So I will write it here 0, 0. This is one term. 0, 0, 0. This is one term. Next 1, double 0. 1, where is 1? This is 1. Double 0, this is 0, 0. Yeah, this is it. 1, double 0. One more. 0, 0, 1. 0, 0, 1. Here 0 is there. Here also 0, 1. Okay. So 0. No need to write these zeros and all. I'm writing so that you people can understand. Okay. I will conclude within 5 minutes. Don't worry. It is already late. So 0, 0, 1. Next 0, 1, 1. 0, 1, 1. So here 0 is there. Here 1, 1 is there. So 0, 1, 1. So in these 4 boxes, write 1. In remaining, you can write zeros. You can write zeros. I didn't write. If you want, you can write zeros in the remaining boxes. In the remaining boxes, you can write zeros. Only in these 4 boxes, you write zeros. Okay. Now, I'm sorry. In these 4 boxes, write ones, not zeros. So these are the ones. Now we have to group. So what did I say? Adjacent 2 boxes can be grouped. Adjacent 4 boxes can be grouped, or 8 boxes, or 16 boxes. So first of all, I think these 2 boxes, they can be grouped, one group. Next, these 3 boxes are having ones, but we cannot group them. So you can group at least these 2 boxes. And this one is addition to this. You can group this box, these 2 boxes. Okay. So total, how many groups do you get? Three groups. Okay. Total 3 groups. Okay. Here I didn't group it. Okay. So this is it. So if you observe here, total 3 groups are there. But if you see, this one is already grouped here. This one is already grouped here. Okay. So if any 2 numbers or any 2, what to say, okay, any 2 grouped variables, okay, if they are already grouped, you can neglect. You can neglect that group because they both are already grouped. If one is grouped, another one is not grouped, then you can consider. If both are already grouped, I'm erasing all. See, this one and this one, they are already grouped with the other numbers. So even if you are able to group this, you can neglect that group. So if you neglect that group, remaining group is, the groups are only 2 groups are left over. Okay, so actually you will get 3 groups. Okay, but you can neglect one of the group. Why? Because they are able to group with some other numbers. Okay, so no need to consider that group. You can just neglect it. Even if you draw it, you can mention that neglecting the group. Okay, now only 2 groups are there. So what is it? Here, let us see the common terms. Here, A bar, A. So it's not common. So on the top, common is what? For these 2 boxes in this group, for this box and this box, what is common? B bar, C bar is common. For this group, on the left side, A bar is common, but and here B bar, B is there, not common, but C is there, C and C. C is common. A bar and C are common. Okay. So for this group, what is common? B bar, C bar is common. For this group, what is common? A bar is common. And one more term, C is common. So our reduced expression is, what is it? A bar C plus B bar plus C bar. You can write B bar plus C bar plus A bar C. It doesn't matter, okay? This sequence, no need to follow this sequence, okay? You can write B bar plus C bar plus A bar C, or you can write A bar C plus B bar C. So are you able to understand? Let me see, do I have any other numerical problem? I have one more, okay, within I'll try to conclude. Okay, I wanted to discuss many topics, but I'm stuck here. Okay, I hope you are able to follow. We don't have enough time, so I'm not even going to ask you whether you are able to follow or not. Okay, so next, reduce the following function. So if you observe here, four variables are there, A, B, C, D. So A, B, C, D means it's a four variable function. So how many squares will be there? 16. 16 squares will be there. Okay, total 16 squares will be there here. So just write down this expression which has been given. A, B, B, C bar D, A, B, C bar D. You can write down, don't write now, just leave it. After the session, when you have time, you can write it down. Now leave it. Okay, so here A, B, C bar D. So A, B, C bar D, A, B, C bar D, I'm sorry, A, B, C bar D bar. A, B means 1, 1, C bar D bar 0, 0. A, B 1, 1, C bar 0, D 1. A 1, B bar 0, C bar 0, D 1. A, B, C, D 1, 1, 1, 1. A bar C, D. A 1, B bar 0, C, D 1, 1. A, B, C, D bar. A, B, C is 1, 1, 1. D bar is 0. A is 1. B bar is 0. C is 1 and D bar is 0. Okay, so this is it. Now, we just substitute that in the K map. Okay, first one is what? 1, 1, 0, 0. 1, 1, 0, 0. So here you see 1, 1, 0, 0. Okay, 1, 1, 0, 0. Put 1 in this box. Put 1 in this box. Okay, next. Okay, what is next? Next one is 1, 1, 0, 1. 1, 1, 0, 1. 1, 1. Where is 0, 1? Check. Here 0, 1 is there. So put 1 here. Okay, write 1 here. Next, 1, 0, 0, 1. 1, 0, 0, 1. Where is 1, 0? Here 1, 0 is there. And 0, 1, here 0, 1 is there. 1, 1, 0, 0, 1, yeah. So 1, 0, 0, 1. Write 1 here. Okay. Next, all ones. All ones means here 1, 1. Next here 1, 1. So write 1 here. Okay. Next, 1, 0, 1, 1. 1, 0, 1, 1. So 1, 0, 1, 1. So from here, go down, write 1 here. Okay. Next, 1, 1, 0. 1, 1, 1 is there. Yeah, 1, 0 is there. So from 1, 1, go to this box. From 1, 0. This is 1, 0. Put 1 here. Okay. Next, 1, 0, 1, 0 is there. So 1, 0, 1, 0. So from 1, 0, draw like this, and from 1, 0 here, you put 1 here. Okay. So this is it. Now I have already told you, you can pair, you can group 4 boxes. So here 1, 1, 1, 1, you can group it. Okay. So 4 boxes you have grouped. Next, one group is formed. Next, again, if you see this is 1, this is 1, this is 1, this is 1, you can group 4 boxes. This is second group. Again, this is 1. These 2 are also 1s. Again, you can form one more group. Total 3 groups. Each group is having 4. We couldn't get any 8 ones. Okay. So I have told you, you can group 2 boxes or 4 boxes or 8 boxes or 16 boxes. So we have got total 3 groups. See here in this, we have got 3 groups. Each group has 4 numbers. Okay, or 4 boxes. So okay, now let us for the red group. Red group, what is common? AB is common for them. Anything else? Nothing. So AB, A, B plus. Next group, yellow. Just yellow. In yellow, check what is common for yellow group. For yellow group, A is common. A is common for yellow. Next here, what is common? D is common. So AB plus AD plus one more group is there, blue group. In blue group, what is common? A is common. Okay. And you see C. C is also common. AC. So what is it? AB plus AD plus AC. AB plus AD plus AC. Answer is AB plus AD plus AC. Okay. So if you remember, the same answer we have got for Boolean expression reduction. Okay. Same answer we have got for Boolean expression reduction. So when compared to Boolean expression reduction, I will show you the same answer. Same equation is there. This is the equation. This is it. Okay, this is the equation, Boolean equation. And what is it? AB plus AC plus CD. See how many steps we have followed to get the reduced expression. Whereas for K-map, simply see within one step you have got this simplified expression. So K-map is far better than Boolean expression reduction. Okay. So if you have any doubts, you can mention in the chat box. Are you able to follow? And this is it. I don't want to proceed. In the title, I have written many things. No, I don't want to discuss all those things now. Just this is it, and that's it. Okay, that's it. For this is it for today's session. Okay, are you able to follow or not? Don't type Y and write something so that I will come to know you are able to follow. Okay, and that's it for today. Okay, I will just give it, I will create the Google form and I will forward it to you once again. I have uploaded the Google form. Check whether it's working or not. After after submitting Google form, just mention in the chat box and leave the session so that I will come to know that Google form is working. It's not working. Okay, I will check. I think it has to work. I could see 12 responses. Is it working or not? Can anyone mention? Anyone else? Link is not working. But anyone who has submitted? But I have got responses, 18 responses. Who are those? You are unable to text your answer. It's okay. Just if you are unable to. Okay, I'll create one more. I'll create one more. Don't worry. I'll create one more. I will create. I have sent two links. Just check whichever is working. Okay, if you have completed, you can leave. I will change the title of this topic. Why? Because I wanted to discuss few more topics in this session, but I could complete only Boolean algebra and K-math. Those who have filled the Google form, you can leave the session. So if everyone have completed, I will just close. So I think everyone have completed. I will end this session. Thank you for joining this session.